Hello everyone, my name is Yui and I'm in group 2. So today I will present about the Miss Maria assessment. So in this assignment, Miss Maria already gave all the students a question, the same with a problem. So now let's turn to the first one, the problem 1. So in the problem 1, we will calculate the total pressure gradient for the value of the skin factor 0, 5, 10 and 20. And after that, you will plot the pressure down, the drawdown per skin. So here you will have the PE minus the bottom hole pressure is equal to this formula, this function. And then by the substitutes, the given parameter here in this table, you will have this one. So when you calculate this one, this thing, you will have this thing 141.2 multiplied with 80 multiplied with 1.1 multiplied with 1.7 and all of them divided with 8.2 multiplied with 53, it will be equal to this one 48 multiplied 6045. And the same thing, the logarithm of this thing, the logarithm between the radius reservoir and the radius of the well bore, it will equal to this one 9.11. And the same thing, you will have this one. When you replace on the parameter and you calculate, it will be this one. After that, you will have the delta P, it will be equal when to multiply this one to the inside. You will have this. Alright, so in here you will have a survey of 4 skin factor from 0 to 20. So the first one, you will have the pressure loss. The pressure loss is equal to 48.6045 multiplied with the skin factor here. And when you replace the skin factor with the 0, 5, 10 and 20, it will have this one. Alright. Continue. You will have the total pressure. It will be equal to the delta P here. Alright. So we have the delta P here. So when you replace the skin factor here, you will have all the result here. And to calculate the fraction of this pressure gradient, you will have the pressure loss divided to the total pressure gradient. So you will have this one. Alright. So after that, you will have the loss between the skin factor and the pressure down, the drawdown. Alright. So as you can see in this one, when the skin factor increase from the 0 to 2 to 5 here to 10 and to 20, it can be seen that the fraction is increased. But in this figure, it's always lower than 1. Alright. So now, let's turn to the problem 2. In the problem 2, you will have the given data here. I already have a table here for you. Alright. And the request of this problem is to what should be its average reservoir pressure to produce the same flow rate. Alright. So you will have the average pressure minus bottom hole pressure, it will be equal to this one. Alright. And you will have two area with the A1 and A2. So it means that you will have the two average pressure with the the average pressure 1 and the average pressure 2. But in the same parameter of the other value and also the same parameter of the bottom hole pressure. So you will have this one with a difference in the radius of the reservoir. Alright. So when you replace the input parameter here, you have this one. Alright. So when you have the average pressure 1 average pressure 1 minus bottom hole pressure, and all of them divide with the average pressure 2 minus with the bottom hole pressure, it will be equal to this one 0.989585601. Alright, so you have the rate here. So by the mathematic method, you can find with the value, because you already have the P1, the average pressure 1, the bottom hole pressure here, you already have here. So then you can skip on, or you can using the Excel 5 to calculate this one. Alright, so you will have the pressure to the average pressure is will at the radius 2 is will be this one, 5,875.6803 psi. Alright, and you can see that you have the P1. The P1 is will be equal to 6,000, but the B2 is this one. So it means that the B2 is decreased. Alright, so you can see when the area is decreased, so the pressure, the average pressure is also decreased with the same bottom hole pressure. Alright, so now let's turn to the problem 3. Alright, here. So in problem 3, I already give you the given data in this table here with the permeability, the initial pressure, the bubble point pressure here. Alright, so the question of this one is they want you to calculate the IPR curve and also the flow rate Q0. Alright, so the first one, you will have the Q0 is will be in this formula here that in the question Miss Maria already give you here. And one more thing, I want to calculate the BT, the N, the skin factor of I and T. Alright, so by the regarding the input parameter here, when I substitute to this formula here, I will have the table here with the bottom hole pressure decrease from 4,350 psi to 0, and the step of the X step is will decrease 5,000 psi. Alright, so as you can see here, the IPR curve is decreased. Okay, and I want to explain one more thing. So in order to be you calculate in BT the N here, so you already have the table in the lecture of Miss Mary. Okay, and you have the pressure. Okay, so you have the initial pressure is this one. Alright, so you will from this one you will have a line here, and you can have the BG here, and also you have the RS here, the resistivity. Okay, so this why I will have some input parameter from the picture, so that I can calculate the BT, the NRS and the NT, and also the flow rate. Alright, and after that I will have a plot of IPR curve here with the downtrend. Okay, it's increased when the bottom hole pressure is decreased, the flow rate will be increased. Okay, so now let's turn to problem 4. In problem 4, they want you to calculate what are the relative contribution to the flow rate from the pressure different above and the one below the bubble point. Alright, so here you will have the permeability and the same thing. I already give you the given data here. Okay, and also in the lecture of Miss Mary, we will have this formula with the J, the QB, the QV. So here, so we have the QV here. So the QV is will equal to this one. Alright, so in the full senses, it will be the QP plus the QV. The QV is this one will be like here, and it's also multiplied with this one. Okay, so the first one I will calculate the QB. So the QB will be equal to the permeability multiplied with the H. Okay, and multiply with the initial pressure minus the bubble pressure. Okay, but in here, in the given data, they already give that the flow rate P, the bubble point pressure is the initial pressure is higher than the bubble point pressure 1000 psi. So in here, I plus with 1000. Okay, so I will calculate the QB here, and after that, when you have the flow rate at the B, you will calculate the J. Okay, and also QV and Q0 in this formula. Okay, after that, you will have the relative contribution from the flow rate. So in here, you have the QB divided by Q0. So right, the first one here, QB is G, QB here is divided by Q0 in this one. Alright, and the same, this one is the percentage. Alright, it's with this one. Okay, it's the percentage of them. Okay, and the 1 minus the QB divided by Q0 is with this one. Alright, so it means that the relative contributions from to the flow rate from the pressure different about is 52.69%, and the others nearly 47.31%. All right. Okay. So now let's turn to the problem 5. The problem 5 here. So in the problem 5, you will have, they give you the bubble pressures, the bottom hole pressure, the Q0, and the pressure here. So you will, as you can see that when you have the bottom hole pressure here and it's larger or equal than the bubble pressure here, it will be unsaturated reservoir. Okay, and you will apply the Vogel method here, so that you will have this formula in the lecture of Miss Maria. She already discussed about this one already, and then you will calculate J, the QB, and the Q0. Alright, and we make a survey from the 3000. Alright, in this one, the 3000 to 0 here. Okay, so here you will have the 3000 here, 3000 here. Yeah, it will be 0. It's nothing. Alright, the Q0 is nothing. Okay, so when it's divided to 2000 and 1500, it will be this one. Alright, so I will have the flow rate Q0 here, this one. Alright, correct. Continue. It will decrease to the bubble pressure. The bubble here is 2130. You have like this. Okay, and you will copy this one. Okay, and continue to the 0. You will have this one. Alright, okay, easy. Okay, so after that you will have the curve here. The curve here in case 1. The case 1 is here. Alright, in the blue line. Alright, with the two parameters in the bottom hole pressure and the flow rate Q0 here. So we have the IBR curve in this case 1. Alright, at the same, you have the K2. So if the bottom hole pressure is lower than the top hole pressure, this one is lower than this one. It will have this case. Alright, it will have this K2. Alright, I'm sorry, it's 1A. I'm wrong. Okay, I just give you another case for this one. Okay, so we have the different. Okay, so when you also the same thing, you also have a survey to 3000 to 0 here. So it's when it downward, it's also increase. Okay. Okay, everyone. Okay, and I also have you at the 200 and 2000 and 500. I will have a same J and the same QB, the flow rate at B. Okay, the same. Okay, and I will change in the bottom hole pressure with the same J and the same QB, and we have the Q0 exchange. All right, and I have the survey here, but in this one, in a given data, they already give you the bottom hole pressure here is larger than the purple hole pressure. 200, 2500 is larger than 2130. All right. So in this one, you just have one curve. Okay. So I will delete this one. Okay. Just one case. Okay. All right. So now let's turn to the problem 6. In the problem 6, you will have 4-point stabilize flow test, this one, and you have 2 questions. The first one will construct a complete IBR using the Fakovic method, and the second one you will construct the IBR when the reservoir pressure declined to 3,500 psi. All right. So I have the given data here, only have here. So the first one I will calculate this one. The average pressure square minus with the bottom hole pressure square, and also multiply with the it's in the milli. Okay. So we have this one. Okay. Just the same. The same. You replace the input parameter here, and we have this one. Okay, the same. And the first one, you will have this one. You use the Vogel method because you can see that the bottom hole pressure. Okay, you will have the survey of the Vogel method, and then you will have the survey of Fakovic. Okay, so the first one with the Vogel. Okay, you can calculate A, B. Okay, the A here, the given A, the given B, and then you calculate this one, and then when you have the A, B, you can calculate the N and C. Okay. So you will have the first one with the question A. So you already have the formula of Fakovic method here. Okay, S will equal this one. Okay, and you will have the survey here. After that, you will have a block here. Okay, so the block here is with the block of the question A. Okay, the question A, you have a block here. The block with the bottom hole pressure is decreased. But in here, you can see easier the IBR, the flow rate here is in green. All right, here you can see that the same with this IBR curve. It's also that when the bottom hole pressure is decreased, the flow rate is will increase. Okay, and the second one. I will have you this one. I'm sorry. So okay. So now I will calculate the CF here by this one. We have a C here and average pressure here. You can calculate the CF here. Alright, with the same bottom pressure here. So in the question B, you will construct IBR here and the same formula. Okay, the same. We have an N here. Alright, the same. Okay, you have the flow rate with Q here, and then you will have the plot here. Alright, I'm sorry, the plot here. Okay, the plot here is the question B. Okay, the question B here, the same IBR curve. Alright, so the same. You have when the bottom hole pressure is decreased, the flow rate is will be increased again. Okay, and here. So here you will have the table, the graph show that the relationship between this column and this column. Alright, you can have the trend line here, and the trend line here is so that most of the point, the trend line is increased with the slope and this one. Okay. All right. So now let's turn to problem 7. In the problem 7, they give you the first one, dry gas. Okay. And they want you calculate the 1 to 8. So the first one, you have the MW. So here I have the formula of MW here. Okay. By you using the input parameter here, you multiply with 28.97 here. Same here. You have the MW here. After that, the PC. The PC is equal to 1. By you using this table, the molecular weight and the critical property of the poor component of the natural gas. So in a given data, you will have this one, dry gas reservoir here. All right, I will mark it, bold it. Okay, this one is dry gas reservoir. Okay, so it means that it will see C1 and C2. Okay, this one. You have the molecular weight of the methane. It will be this one, and the ethane is this one. The same. The critical pressure is this one and this one, and the critical temperature is will be this one and this one. Okay. So here I can calculate the BC, and the same the TC. I also use this table to calculate this one. Continue with the PR. The PR is will be the pressure initial is will be divided by the PC pressure. Okay, the basic critical temperature. Okay, continue with the PPR the PRA. The same. You have the PC, the PA here. You will divide it by PPC, the basic critical pressure. Okay, the same. And the TBR here you have the T is divided this one. Okay, easy. It's okay, easy. Continue. The Z here I already have it because I use this table. Yeah, so when you use this table, you can have the Z, the compressibility factor Z. Okay, you have two things in here. The same, we have the BG and BGI and BGA. Okay, by this formula. Okay, you have the Z, the compressibility factor Z you already have, the temperature you already have too, and also the pressure you already have. So it's very easy for you to calculate two of them. Alright, and continue with the G. The given data already give you the area, the H, the porosity, and the saturation gas. Okay, and you already calculate this one. Okay, so you get this one. Easy. Okay, and the last one, you will calculate the recovery factor for this well. So the recovery is will equal to 1 minus to this one. The BGI is divided by BGA. Okay, so here is all the result for problem 7. So now let's turn to problem 8. Alright, in problem 8, you will have they want you to construct the IBR curve again using the equation given below. So here is the equation that Miss Maria already gave in the assignment, and also they want what would be the well deliverability if the flow rate wellhead pressure is 5,000 psi and plot the IBR and the VLV curve. Okay, so the first one we have the given table here. Okay, with the A and the B. So where's the A and B? A is B is with this one. A here and B is here. Okay, so when you replay the input parameter here, you have the A and B. Okay, and the same, you will have the bottom hole pressure is degree. Okay, when it is degree like this 1 to 500 here, and the flow rate here is will degree the same. Okay, it will increase the flow rate here. So the same with the other IBR curve, I will have the IBR for this one for here. Okay. So the question asks about the wellhead at the 500 psi. So at 500 psi, you have the flow rate is a 3,220, 280. Okay. Okay. Is it clear? And the VLP. So VLP, you need to have a skin factor. It's here at your skin factor is this one. Okay. And I calculate the NE, the recover, no, the Reynolds number, okay, and the FF, the BTF, and the BWF again, okay, and then I have the plot between the BWF here and this one. We have this line, this one, okay, it's between the bottom compression here and the flowing here, okay, it's like this one is like the real, okay, the test, and this one is the eyebrow curve, okay. So as can be seen that in this one, it's cut here. Yeah, it's nearly at the flow rate is 3,164 with the pressure is 1,034.87204 in BSI. Okay, so here is on the result for the assignment. So if you have any question, I would be grateful, and I can answer every question. Okay, thank you for listening.